have used also principal component analysis. We have seen that it can be applied for high frequency information. And we have been able to change our dynamic factor model also to include high frequency information. Okay? In other Kalman filter applications, we have seen in particular time varying coefficients. Okay, this is all you learn in this section. Okay? Okay. In topic 2, we saw macro switching. We have seen macro switching univariate. We know that it's a mixture of normals. We have talked about the properties of mixture of normals, and it's a parsimonious way of representing a rich amount of density functions. We have mentioned multivariate. We didn't go too far with this because we need Bayesian analysis. I'm going to basically close this part today. There are some things that we can close properly, some things that we can close just like I will tell you how to close this thing just in case you want to close this. But I mean, this requires more work and more time, and I think this is enough. Okay? With an excuse that you have in topic 7, because I don't know where to put this thing, then you have here univariate. We have seen all the details of univariate. As I said, in the multivariate, I just mentioned a few things. Here you have something called additional material. There is a couple of papers that I would like to mention today too. Okay? Obviously, we have seen macro switching time varying. That is the last thing that we have been working on. There is no way. Okay? And then mixer is what you have here. Macro switching time varying. Again, I will mention this thing. I will introduce you to all these topics today. As I said, I want to finish up a couple of problems that we have. But at that time, I didn't want to spend more time on these things because to go all the way with this thing, we have eaten the part of VAR and local projection, and I wanted to make sure that you don't go very deeply into this and you will forget something that is also necessary. As I said, we will finish this thing, or we will finish this thing as much as we can finish this thing. Don't worry, if there are more things that we haven't covered in class. I will never ask something that we haven't covered in class. Okay? You have seen my exams, and everything that I ask in the exam is something that we have discussed or we have talked. And never ever I have put in the exam something that we haven't seen in class. Okay? Then you have more materials. Because I put the material, I try, but I have to see the audience too, okay? And I have to evaluate the needs of the people, of the things that I think you need more for your future, and there are things that I like it a lot, but there are details. Okay? I mean, what is left here is more details. Okay? I will, as I said, in the additional material, I have a couple of papers that I would like to at least mention to show you that the kind of things that can be done with these techniques. Okay. Then in topic 3 we have seen VARs. Okay? We have seen VAR in a lot of depth. Okay? We have seen estimation of VARs. We have seen estimation. We have some equal response functions, and I pay special attention to structural VARs, identification. The probability 1, you will have questions about this. Okay? Okay? The probability 1, you will have questions about that. Okay? this in detail. You have a code that do all these structural VARs. We have seen 3 ways of doing identification. And when we talk about sign restrictions, they give you the possibility of doing other type of identification that you can find in the literature. Because, as I said, instead of you play with the rotations in order to match something that is in textual analysis, that you can make sure that the shocks are similar to whatever you want, either shocks or any type of external information that you want to tackle with your shocks. Okay? Then next class that we didn't finish the other day is local projections, okay? And I want to finish up with, today with local projections. And I have it in the same topic, but it's a different one. The thing is, like, given that I want to talk about quanti-local projections, I'm going to include another topic that is quanti-regression. And I want to finish today's class with threshold models, that is the topic C. Okay, this is what is left for today. And in addition to that, you have topic 7, that is Bayesian econometrics. Okay, but we have covered here. Okay? I promise that you have learned a lot. Okay? It's a lot. Okay? Yes.
Before we move on, I just wanted to confirm something on
On the
VR.
yeah, yes.
It's just in the
Okay.
here.
You want me to put the notes on the yes? Where is it? This page? 15? Okay, yes.
On the economic interpretation
Uh-huh.
of the
Which are the monetary shocks
yeah.
do not affect YD on YD with the same quarter. The inflation shock does not affect YD with the same quarter. Or will react to, no, it's, sorry, that's interest rate react to also very good cuts. Okay? Interest rate reacts to all the shocks. Okay? Very good cuts. Okay? This is a typo. It's not open, it's interest rates. Okay? Very good cuts. Yes.
I want to ask something also about when
It's already got caught, okay? She already got the cut. No, I also. I also got the cut.
yeah. So when in sign restrictions,
Yes.
that is like it is like 30.
Should I go?
Yes, please. Like,
It's 13. Yes. Okay.
I don't understand that the random X
Mm-hmm.
and orthogonal are to find new Qs, like to find any Q that's gonna be.
Okay. You understand that you understand that we have Q of Q of the Cholesky. Okay? Here? I mean, what I'm saying is you have Q of Cholesky. You have Q of Cholesky. Okay? And you know that Q of Cholesky times Q of Cholesky transpose is equal to 0. Okay, this is what you do. Okay? In addition to that, if you happen to find a matrix R that is orthogonal, basically all the and and the variance variance matrix of the. If you happen to find a matrix that has this property, okay, you understand that you could put here will be also equal to sigma. This is true. Okay? Then what I'm saying is like what you have here, QC times R is a matrix that now is full of numbers, but it's also satisfied this thing. Okay? And the only thing that you need, and this is the beauty or the inconvenience of identification, is saying that this is as true as this. It's just a different decomposition. Okay? Because the only thing that is true is this. The only thing that comes from the data is this. How do you decompose this data, this variance covariance matrix, into two different matrices? It's not, I mean, in the same way that QC is lower diagonal, but could be upper diagonal. Okay? It will be also a possibility. Okay? Then the only thing that I'm saying is that this is a matrix that is also valid as a decomposition of the matrix. Okay? How can you get this type of matrices? How do you get a factory of this type of matrices? There is something called QR decomposition of a matrix that is basically a way of decomposing a matrix, any symmetric matrix, into two matrices. One that is orthogonal and the other that is lower diagonal. This is also always true. Then you can create matrices that have this property, and you can always decompose matrices with QR, with this command QR, into two matrices. One that is orthogonal and the other, one that is orthogonal and the other that is lower diagonal. Therefore, I have a factory of orthogonal matrices. Okay? It's just a way of creating this factory. Okay? Then this is just a procedure to create matrices that have this property. Okay? I'm going to, it's the same. Imagine that you could do it by hand. Okay? You can put it by hand. Try to put by hand 10,000 matrices that have this property. It's a pain. It's just a way of generating this type of matrix. Okay? And then the only thing that I'm saying is this is a valid decomposition. And this matrix Q, QC times R, contains 9 elements. And now the only thing that you have to check is these 9 elements have the property that you want. Say, this is positive, this is positive, this is negative.
Multiply first.
What?
You have to multiply that.
You multiply this times that.
And then you multiply by the whole.
No, because remember in the word decomposition, when you have YT, the first element of UT is the identity matrix. Plus, then you have the second element, P1 plus P2, okay? But this element is the identity matrix. Then when you multiply this thing by QCR, you don't need to, okay, here you have everything that you need. You have shocks, okay? This is the reduced form wall decomposition. Okay? The reduced form, I'm telling you, in the reduced form, this number is this matrix is the identity matrix. Okay? By construction, we have seen this thing. You go backwards, and then you have YT is equal to UT plus V1 UT minus 1, and UT has the identity matrix. Okay?
Yeah.
Yeah. This is the identity matrix. Then when you say, oh, but UT is equal to this times epsilon, okay, then you do this times epsilon, and this is what you do structural decomposition.
And that will be
UT is equal to Q times epsilon, okay, and then this is going to be and this matrix is going to be QC. And now you can check the restrictions on it.
And you identify the shock on time, just time t. So
You can have other type of restrictions. Okay, you can say, I want to define a shock that is positive here, 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 and here. And you check if this is true. Okay? You can define any condition that you want. Okay? From this 10,000, the more restricted you are, the less are going to satisfy your condition. Okay? And then perhaps you don't need to do 10,000 iterations, you need to do 100,000 iterations in order to get 1,000 input responses. Okay? And the more restricted you are, but you can put any restriction that you want. Okay? That's it. Okay? In order to have a family of input response functions that satisfy the condition. Okay? Yeah? More questions? No? Okay, then coming back to the review of the material. What I want to cover today, as I said, I want to finish up a little bit this thing. Okay? And I want to show you, in Bayesian econometrics, I want to show you, remember we have seen here time varying coefficients, okay? But I want to show you the possibility of doing time varying VARs with all the coefficients of the VAR changing over time. In order to do that, thanks God, we have seen already Bayesian econometrics, and you are going to be able to apply your Bayesian econometrics knowledge to time varying VAR. All the coefficients of the VAR changing over time. What is the other things that I have to finish is local projections, quantitative regression and threshold models that are going to be local projections. I just will spend 15-20 minutes. I want to tell you the problem with local projections, okay, and how to solve these problems in the best possible way. And the other two topics are going to be very short ones. Okay. I'm confident that today we are going to see everything that we look forward. And then what I'm going to teach you tomorrow is the last thing that I want to teach you is and the stochastic probability model. Okay, I want to show you this slide. Okay, and that will be it. Okay. I promise that you have, if you understand all these things, you have all the background that you need to work anywhere. Okay. There is no anything that they can tell you that you don't know. Okay. And this is what I want to make sure that you need to master with all the technical knowledge that you are supposed to have. Okay. Then let me finish with quantitative regression. Remember the idea, quantitative regression are linked to VAR, okay? And when people use quantitative regressions in the TFM or whatever, they don't understand VAR, it doesn't make sense. Because the essence of input response functions are in the VAR, okay? In the word representation and things like that. Again, it's not that you have to do all these things every time that you do a VAR, but at least when you see an input response function, you can imagine the word representation, what is behind, that you are multiplying by something, okay? And you understand what you are plotting, okay? From in a deep way, okay? And I want to make sure that you understand this in a deep way. Then, what do we do with local projections? Remember the idea of local projections? It's the thing that we were seeing the other day. Remember the idea of local projection is saying like, okay, it's a pain to estimate a VAR, why don't you put just the shocks into the model, okay? You have determined the shocks somewhere and understand the relation between the shocks and the variables at different horizons, okay? Basically what you are estimating here are the coefficients of the input response function of the VAR, okay? How one shock in period T is equal to the variable in period T plus 1, in T plus 2, in T plus 3, in T plus 4. Okay? therefore it's kind of a shortcut to talk about import response function in a extremely compact way. Okay? Then when you estimate this type of models, okay, basically what you are obtaining, and I hope that you understand the relation between this and estimating a VAR, what you are obtaining is basically the coefficients of the import response function. Okay? Is that clear? No.
Not so,
No.
not so much.
Okay, let's rewind a little bit. Let me go to the VAR. Do you understand in a VAR that when we go here, I don't care about the decomposition. But when we go here, you understand the that what I'm plotting, what I'm doing here is all these coefficients theta are the representation of the coefficients of an impulse response function. Is that clear? Okay. What? You don't understand. You don't understand. Okay. Okay. I don't know. I spend a lot of time on this. Okay. Telling you that these are the coefficients of an equal response. Okay. And these are the basically how one solve the things that lead to all the coefficients in all the y's in different regions. Okay. Therefore, when I'm plotting an impulse response function, I'm plotting elements. Let's say, if I give you, let me see. If I give you, if I tell you that theta j is equal to if I tell you what's the meaning of this coefficient, you can tell me what's the meaning of this coefficient. If j equal to, imagine that j is equal to 4. Okay? What is the meaning of this coefficient?
How the shock is affecting your second variable.
How the shock in period t, because it's 0, t minus 1, t minus 2, and t minus 3. Fine. J equal 4, then be careful with this. J equal it will be 0, j equal 4, this is t minus 4.
Okay, so
Okay, so shock in period t is period 4. How shock 4 periods before, or how shocks today are going to affect
the following,
the following what? How shocks today in period t, which shock?
shock number
2.
2. Okay.
No, the first shock number 3 is affecting,
Or it's going to affect
is going to affect
your second variable.
the second variable for periods. Okay? Okay? This is the meaning of that. Okay? Therefore, if I plot this in 3, 2, in 1, whatever, I have the impulse response function of how shock in period t is affecting the variable in t plus 1, in t plus 1. Okay? This is what I'm doing. Okay? Then look, this is a question of talking about shocks. And in order to talk about the transition of shocks, I have to estimate the VAR and I have to do all these work.
So can you give one more time the meaning? How T-4 affects shock number 3?
How shocks today affect what? J equal 4. And I'm talking about this, okay? This coefficient. How shocks today, which shock, how the third shock today is affecting the economy for this effect.
So you say
The
that-
second variable.
That's a leading variable.
What?
So we say that's a leading variable.
No. No. Why? What is this variable? These are shocks. Okay? I'm not talking about leading, I'm saying that it's the addition of shocks into the economy.
Okay, I think it's a leading variable.
Okay. Okay, then in order to calculate these coefficients, I have to estimate the PAR, I have to calculate all the dynamics of the system and all that. But then the point of Oscar, the local projection, is saying that, you know, if you can isolate. The point of Oscar is saying that if you can isolate these shocks somewhere, somehow, okay? Basically, imagine that you can get these shocks from a different source. Let's say somebody is reading the minutes of the central banks and then tell you there is a shock here, there is a shock here, there is a shock here, there is a shock here. It's the same as interest rate that are not justified. Okay? You have the shocks from an outside source. You don't need to estimate a VAR and all that thing. You can put the shocks in the system and you relate the shocks with a variable in t plus 1, in t plus 2, in t plus 3, and basically all these coefficients that you can get in this regression at different horizons is going to be the coefficients of the VAR that you are plotting, because this is how one shock in period t is transmitted to t plus 1, t plus 2, t plus 3, t plus 4. Okay? You don't need to estimate a VAR. You can do this regression. Okay? Two things. If we are talking about, here imagine that we are talking about growth rates, okay, then you have growth rate, these are shocks, and this is how shocks in period t are transmitted to growth rate of the economy in t plus 1, in t plus 2. This is exactly what people have in mind when talking about impulse conference. Okay, but we can have also the effect on the level of this variable, okay, or the variation from t to t plus h, saying like it's not what's going to be the growth rate in t plus h, is how much the economy has been affected from period t to t plus h. Okay? Is the accumulation of t plus 1, t plus 2, t plus 1, t plus 2, up to t plus h, the accumulation of shocks. Okay? Then, in order to, if you want to talk about the accumulation of shocks, and this is actually something that we are doing right now, okay? Let's say we have had, we are worried about, we are worried about what's going to happen with the price of food in the next few months, because usually price of food react to oil prices with some lags. Why? Because at the end of the day, oil prices increase. Obviously, gasoline prices increase, transportation prices increase, the price of fertilizers, okay, imply all these things. And then, actually, yesterday I was doing these plots. Okay? Okay, how, let's say, for example, in this case, how oil prices affect the prices of eggs, okay? And 15 to 20 months later, okay? Because at the end, the transmission of oil prices are affected to every product any food product, okay? This is how the prices are going to change the price of yogurt. This is how this is a local projection. Okay.
Okay. So if you look at the projections, the confidence bands, how do you calculate them? The same as
Okay,
the
no. Be careful with this, okay? I will complete this. Okay, I'm going to tell you what to do. Okay. Okay, but basically, this is something that I was asked for yesterday. Okay, what can we expect for the price of food for every element of the food? Yes.
I have a question. It's not like about this in specific, but when I was doing my project, like I was a bit confused between nowcasting and forecasting, and like where would you say is like the limit? So like the
No, I think you don't tell what's going on now.
No.
And if I'm asked what's going to be the growth rate in the second quarter of 2026, this is not casting, because I am right now living in the second quarter.
Okay.
If they ask me what's going to happen next quarter, this is forecasting. Because what's going to happen in the future.
Mm-hmm.
And if I'm in April and the number from the first quarter has not been published yet, and they ask me what's the number that is going to be published for January for the first quarter, this is backcasting, not forecasting the past.
Okay.
And backcasting is forecasting the past, nowcasting is understanding what's going on, and forecasting is what's going to happen when they are asking me for a quarter in which I'm not right now.
Yeah, but when you nowcast, you are also predicting information that you.
Yeah, but if I am nowcasting, if they ask me what's going to happen in July, okay, I am not living in July. When they ask me what's going on in June, I'm living in June. Obviously, I have to forecast the next few days in June, but they are asking me what's happening in the month in which I'm living.
Okay.
That's nowcasting. However, if they ask me what's going to happen next week, that's forecasting. Because I'm not living in next week, I'm living in this week.
So depending on where you position yourself now,
Exactly.
depending if you're saying I am in June or I am in week 1.
Exactly. Right now, if they ask me what's going to happen tomorrow, that's forecasting.
Vale.
But what's happening today is no casting. But if they tell me what's going to happen tonight, that's forecasting.
Vale.
Okay, depending on what is the question.
Okay.
It's no casting, no forecasting.
Vale, vale.
Okay, but the point here is saying like, what is the transmission of shocks? Then, in order to calculate these functions, I don't need to do a VAR, okay? Because I have oil shocks, and the only thing that I have to do is regress the prices of these commodities, or the prices of these products, variation in prices of this product with oil shocks, okay, at different horizons. But look, I guess you understand, when I'm plotting here, it's not, what I'm saying is like, you know, the change in prices in pescado seco y salado in 10 months is going to be 0.2. I'm saying the change in prices from now to 10 months is going to be 0.2%. Accumulated. Okay? Because this is what we want to know. Is, you know, if we are going to have, you know, in September, like people are going to say like, okay, all the prices are really up, whatever, okay, we can't stand anymore, we have to be a kind of in front of, be prepared for these things. Okay? Then, in order to do that, you understand that I don't need to have a VAR with oil shocks. I have enough to understand what's going to happen. Okay? But in order to do this impulse response function, what I said, I did yesterday. In order to do this simple response function, I have to do these variations. Okay? Shocks here, and then here I can have two things: either inflation with variation in prices that will not be accumulated, or I can define this function as the variation of prices of this particular product from period T to T plus H. This is the accumulation. Okay? It's like what's going to be, in this case, is CPI. And right now I'm talking about the prices of cereales, huevos, okay, one by one. Okay? The prices of all these things at H periods horizon. This is what I'm trying to focus. Okay? To focus, not to understand how it's going to be the transmission from shocks in period T to prices from T to T plus H. Okay? Then, how I calculate the shocks? Okay? The price of Brent minus the Brent T minus 1. This is how much oil prices have gone up this month. Okay? And I want to relate with the prices of this product in the next few months. Okay? In order to do that, as I said, I don't need to do a VAR. I can do this thing. I can regress. First of all, the prices in contemporary response. How much prices of huevos have increased this month with respect to the stocks in this month? Then what do I have? What is the regression that I have to do? I have the change in price of X and the price of oil prices from the beginning to the end, okay, from 1980 to today, and the price of X from 1980 to today, and I made this regression, and this is telling me what is the immediate transmission of oil prices into the prices of X. Okay? It looks stupid, but we have to talk about these things, okay? People worry about the price of X, perhaps you don't, but you know, people care about these things, okay? Price of eggs, tomatoes, whatever, and we need to understand because, you know, poor people is actually the one that spend more money on food, okay? And you want to understand how much salaries of the lowest quantile are suffering the world. You have to check how much these products are going to increase in price in the next few months. Okay?
But
Yes.
if you have only data, if the shock is today,
Yes.
you don't have data enough to do.
Yeah, but I have a whole history. Okay?
But imagine that the shock has happened today.
Has happened this month. We are doing this
Okay.
in month. Okay? Then I have a whole history of oil prices. Imagine that we are talking about increasing oil prices in Europe. Okay? And then I have the whole history from 1980.101 until 2026.06. This is oil prices. Okay? And I have the variation in the price of, let's select something, one that is really stupid. Okay? Fresco, este es el average. El que más os guste, marisco fresco, leche desbandada, otra leche, bebida vegetal, queso, I have all the products. Okay, queso, okay? The price of cheese, okay? Then I have the variation in the price of cheese every month from the beginning to the end, okay? I can make the regression. And then I can calculate how contemporaneously oil prices affect the price of cheese.
So,
And therefore, if I have an increase in 20% in oil prices, 20% times beta, give me what's going to happen with the price of cheese. What do I expect is going to happen?
you are assuming that every change of oil price is a shock.
Every change in oil price is what?
It's a shock.
It's a shock, yes. We are going to talk about this.
But not always it's a shock.
We are going to talk about these things. Do we need to instrumentalize the oil prices, or can we consider oil prices a shock? Okay? The whole purpose of local projection is up to what point the shocks make sense. Your local projections are going to be as good as the quality of the shocks that you are putting in. Okay. Yes.
When you said the left, you have the variation in price or the price?
The variation in prices.
But then when you identify in the
Contemporaneously, okay, be careful. Contemporaneously is variation in price. Okay? And now I'm going to do up to one period ahead. Okay? Then what is going to be my left hand side variable? It's not with, okay, this is very important, okay? Because a lot of people is confused with it. What I have here, as you are saying, is the price of cheese. Okay? And you know that the price of cheese, how do we calculate the price of cheese? The statistical office goes to the same supermarket every month and every day of the month. Let's say on the 12th of every month I go to the supermercado Día de la Calle, whatever, and I try to buy un cuarto de kilo de queso de cabra, de whatever. Okay? They buy the same product. Okay? And then with the basket of goods, with the survey of condiciones de vida, they ask people how much they spend on this type of service. Okay? Then basically we know how much people are buying every type of cheese. And every cheese has their weight according to the basket. Okay? Then we have an average.
Sorry, would the prices of cheese in different zip codes will increase?
What?
Would the prices of cheese in different zip codes in
Yes.
different supermarket? Is there
We
like
put
a
the average. Then imagine that we
An average.
consider. Then we have a CPI for every autonomous community. But when we talk
like
about
include the
price
poor
of cheese,
neighborhoods and the rich ones in the same one, or you
it's
could just
the
like
average of all the products in Sweden. Okay, all the zip codes. Okay. Then basically we know the price of cheese every. Okay, we have all the prices of cheese. Okay, prices in levels. Okay, and then for the first regression I do growth rates. Okay, regression in period T, I do growth rates. Okay, prices in T minus prices in T minus 1. This is going to give me contemporaneously how each shock in oil prices is going to affect the price of cheese. Is that clear? Because I'm talking about shocks, I'm talking about variation in oil prices. And then, in response to your question, if I see oil prices going up in 20%, I will expect that cheese is going to go, this increase times beta is going to give me the effect on cheese here. Okay? Clear? In the second regression, I have to do one month ahead. Then it's going to be prices in cheese level in T plus 1 minus, in T plus 2, be careful. This is in T minus 1. Okay. If okay, in T plus 1 minus cheese in T minus 1. Before I did T minus 1, and now I'm going to do T plus 1 minus T minus 1. And I'm talking about two months ahead. Okay? Then look, you understand that now I have a whole time series of variations of 2 months horizon. Okay? And then I can make a regression of this variable on shocks. And this is what happened at 2 month horizon. And then I'm going to create another variable that is going to be T plus 2. And it's going to be cheese in T plus 2 minus cheese in T minus 1. Then it's going to be 3 months horizon.
What I don't understand is if your Y, like the race is in growth rates, then the shock you're identifying the change in growth rates.
No.
If it's in
Okay,
levels,
this is levels.
that's
Okay?
levels.
The first is growth rates.
But then
And then the second is 2 lags of the levels. Is variation at 2 month growth rates at 2 month
so
horizon.
then when you identify what the changes in the shock are going to identify the changes in the growth rate. That's what I don't understand. You want to identify the changes in levels?
You want to know how something that happens in period T affects the variation of prices, variation in prices.
But that's why Y has to be in levels to identify the variation in levels.
This Y is 11, but I'm doing here the first growth rate, the second is two variation of the levels 2 months ahead, the variation in the levels 3 months ahead, and the things that I'm going to regress is this variation, these growth rates at different horizons, representing variation, obviously growth variation in the levels.
But Y is, when you read Y in the Excel, is in growth levels.
Yeah.
Why? The Y.
When you don't load the data, you don't load the data of prices of cereales, of prices of huevos, okay? Imagine that you have 110, 111, 117, 100 the prices, okay? And then if you have a shock in period T here, okay? You have variation in oil prices here, you want to regress variation in oil prices, you can define this thing, what's going to happen here, or what's going to happen, you can talk about, be careful with these things, okay? You can put here shocks in period T minus 1 and variation in prices in period T, okay? Let's say, I have a shock here. Okay, I have the set of shocks. This variation in growth rates of oil prices, okay? And now I have to be careful with the definition, okay? Let's say, I want to know how much this is going to affect, how much this is going to change prices in the future. Change prices. You don't want to know the effect on the level, you want to see the variation in the change in the price. The effect on the change in the price. Okay? Then we can make this regression. We put shock in the 2 minus 1 and then it's going to be more good. You put a shock in period T minus 1, let's say shocks here, shocks happen here, and you want to know how much prices change from this to this. Okay? Shocks that happen here are going to affect prices in the next month. Okay? I can put shocks in period T. Okay? And then I'm going to talk about variation in prices in from t to t plus 1. Okay? Clear? Then I have to define, for the first regression, I have to define yt as the price in t plus 1 minus the price in t divided by the price in t. Is that clear? This is how shocking period t is going to affect prices tomorrow. Okay? If I want to know how shocking period t is going to affect prices in the next 2 months, I have to do it. Okay? And if I want 3 months, and then I have to do this regression and the regression.
That's accumulated.
Which is the accumulated change from t to t plus 1, t plus 2, t plus 3. Okay, this is the thing that they want to explain. Okay? So the plot that you are here. But something that could surprise you is that the standard error bands are huge. Okay? Why are huge? Okay? Because you could think like, okay, these are the things that I'm looking for. Okay? Beta 1, beta 2, beta 3. Okay? These are the things that I'm looking for. These betas. Okay? This is how one shocking period t is that leads to prices in t plus 1 over t, depending how we define it. Shocking period t that will lead to prices tomorrow. Okay? Up to 2 months ahead. Okay? And I'm going to define these things like this. Okay? These are the betas that I'm looking for. Then you can say, why you do the OLS and you calculate these betas, you have the standard errors because these data you estimate by OLS, you have the betas from the estimation, beta x prime x prime y. Okay? Sorry, sigma square x prime x prime. But the thing that I told you the other day is that we have a problem with the betas. Okay? The problem with the betas is the following. Imagine that we are talking about 3 months horizon. Okay? Then a 3 months horizon, what I have in the left hand side, you understand that is basically the log of CPI in t plus 3 minus the log of CPI in period t. Okay? That this basically contains information about the variation from period t to t plus 1, the variation from t plus 1 to t plus 2, and the variation from t plus 2 to t plus 3. The next observation in that regression, the next observation is going to contain, okay, this is variation. Let's say I do this variation a 3 months horizon, okay? Next observation, you're going to have another 3 months horizon. Next observation, you're going to have another 3 months horizon. But as you can see, the horizon overlaps. Okay, there is information contained in the same information at different horizons. Let's say a period t plus 1, you have information from CPI in t plus 1, in t plus 2, in t plus 3, in t plus 4. A period t plus 2, we have CPI in 2, 3, 4, and 5. Okay, we keep increasing the horizon, and there are some variables that overlap. Let's say, obviously, this is very much related to this because they contain this animal, they contain this animal, and they contain this animal. Okay? They have the same information. Shocks are not by ID, shocks are correlated. Okay? And I told you the example, if your grades are correlated, the variance increases. Okay? Because you know, if you have a good grade in my class, you are going to have a good grade in the next class. Okay? And grades are correlated. Okay? That's why I have this pressure in the grades. Okay? Because grades are correlated. Then you have to estimate these things with a lot of care. What I do here is give you a basic explanation of how do we calculate autocorrelated errors. Okay, in particular, you estimate a model by OLS, you have beta, x prime x, x prime y. Okay, so the estimation error is this, the variance is this one. Okay, and here is when you have the problem of errors that are correlated. Okay, if errors are correlated, this animal gets bigger. Remember, the only thing that I have done is calculate beta and say like beta is the actual, this is beta hat, okay? You put beta hat in the model, x prime x, x prime y, and y is equal to this, then beta is equal to beta hat plus this thing, okay? Then beta minus the true value of beta, these are basically the error, okay? The variance of beta comes from this animal, and the variance of beta is basically driven by this. when you have this that is huge, okay, because errors are correlated, the variance is going to increase. What is the meaning of that? And this is what I try to do here. What is the meaning of that? This is what we do when we multiply x prime epsilon, okay? And this is what I am trying to illustrate here. And the only point that I am trying to do, when you multiply x prime epsilon, you have terms like E12 times E22, okay? All these things, that when they are not correlated, they increase the value. How do you calculate these things? How do you calculate error with autocorrelated shocks? Okay? There is something called Newey-West estimate. Okay? Basically, the idea of Newey-West is calculate the standard variance plus calculate the error that comes from the increasing variance that comes from the autocorrelation. Okay. You don't have to worry about this thing, okay? If you go to anything to put Newey-West, the only thing that I want to make sure is why we use Newey-West, okay? Because errors are correlated. We need to take into account the error. Imagine that the standard error bands are huge when I do Newey-West, as you have seen in the graph. Imagine that I decide I don't want to use Newey-West, I decide I use the variance of OLS. Can I do that? You understand my point? It's saying like we are going to use the Newey-West band. And that implies that my standard error band, I go to the vice president, Carlos Cuerpo, and I say like, no, I have huge standard error bands. I prefer to plot smaller standard error bands. Imagine that I decide to put the standard error bands that come from OLS, that are going to be smaller. Can I do that? No, I'm not. I'm lying. Okay? I'm saying that I'm more certain about things that I'm not certain about. Okay? I cannot do that. Okay? You have to use the tools that are appropriate to calculate the uncertainty that you actually have. You cannot do that.
That's merely biased.
No. It's a question of the variance, the uncertainty. Okay? You have more uncertainty than the groups. When you estimate or less, okay? You have less uncertainty when you estimate with Newey-West, you have less. Okay? Then what else? Then you have to do local predictions. You see, you have to do Newey-West estimate. Okay? The second thing that is also important, and this is the thing that I wanted to point out, is what kind of shocks are we going to put? Okay. Then, and I mentioned this thing the other day. Remember that only in our previous class of VAR, we have defined 3 monetary policy shocks. Okay, we have defined in the first Cholesky composition, I defined monetary policy shocks are those that do not have a contemporaneous effect on the other variables. Okay, I defined this thing. But later in the class, I define a monetary policy shock to that thing that has a positive effect on GDP, positive effect on inflation, and negative effect in interest rate, or positive, negative, positive. These are monetary policy shocks. Okay? Then we have 2 definitions. But in addition to that, we use Danza and Qua, and we find definition on the long run of the other variable. Okay? We have 3 definitions of monetary policy shocks. Then when we put into our local projection shocks, imagine that we put in local projection a set of shocks. What kind of shocks are we doing? Okay? That's something that you need to be aware of. Okay? Then a lot of people say like, okay, I'm putting shocks because I'm reading the minutes of the meetings, and I realize that here and here and here people make decisions. Okay, and therefore these are going to be the shocks. Fine. Okay. The quality of the way that you read those readings is going to be important in order to calculate basically going to be key in order to understand the correspondence. A lot of people, what they do is say like, okay, I'm going to estimate a VAR, calculate the shocks, and then I put the shocks in local projections. in order to calculate import response function. But if you do that, it doesn't make any sense because you already have in the VAR, you already have the import response function. Okay, you don't need to do this. You know, it's two things. Okay, therefore it's kind of a circular argument. I use a VAR, I calculate the SOX, and then it's kind of circular. And then I don't recommend you to do that. But what people do, on Monday I was in a dissertation committee, okay, and this guy was doing fiscal SOX, okay. And then he said, I use the fiscal SOX from this paper, and then from this paper, and then from this paper, because this paper has fiscal SOX from this period to this period, and the other fiscal SOX from this period to this period. But you know, these papers, they have different definitions of the fiscal SOX, therefore you cannot put the SOX together, because I don't know how we can define the quality of the definition is going to be key, and the fact that you have different sources implies that I'm not sure if the SOX talk to each other. Okay, then you have to be aware of this. It's like it's not a free ride. It's local projection because you need to define the SOX. Obviously, there is a natural way of defining the SOX. If you have a variable that you consider, as you have here, let's say you ask me about SOX, oil prices. Okay, oil prices are SOX or not for the Spanish economy. There are two things, okay? Oil prices move because the economy moves. Okay, you can say, yeah, but Spain is a small open economy, therefore it's not going to change oil prices. We are not China, okay? China moves and then oil prices increase. But we move and nothing happens. We are small. But we move we move could be a proxy of everybody's moving. Therefore, even though we are not causing oil prices going up, we move with the world, and therefore part of the prices could be endogenous, not because we are doing this thing, because we contain information about variation in oil prices, because we are part of the world, and we increase when the world increases. Okay? Therefore, the point is like SOX should be completely unpredictable. And if I do a regression between Spanish growing and oil prices, I see a positive effect. Okay? And not because we are causing this thing, it's because we are moving with the world that moves oil prices. Okay? Then it makes sense to clean up oil prices. Okay? I'm talking about SOX that are complete SOX. Let me give you something else about this. You have some of these. Look, what a lot of people did was to say, like, talking about monetary policy SOX, was saying like, okay, let's analyze if there is a monetary policy SOX. And we are going to look at the, you know that monetary policy SOX are decisions about interest rates. Okay? Then something that you can do is to make sure that you isolate the SOX is to say like, let me, and then you know the effect when the Federal Reserve or the ECB change the interest rates, the things that happen immediately is that there is a variation in the interest rate in the market. If they decide to increase interest rate, the interest rate in the market increases. Okay? Why? Because we know that when the banks are going to increase interest rate, we know that the main refinancing operation, basically the operations between the ECB and the private banks, we are going to provide funds at a higher interest rate. Therefore, all the interest rates in the economy are going to be higher because they know that at the end you are going to have a higher price for the residual. Okay? Therefore, we are affecting what is called the yield curve. We are affecting the short part of the yield curve. Okay? And the shocks are transmitted into the whole. Great. Then, to all the horizons. Then, let's look at the yield curve 15 minutes before the decision. Okay? Then let's analyze the interest rates 15 minutes before the decision. And let's analyze the yield curve 15 minutes after the decision. If there is a change in interest rates only because of this 30 minutes window, that's a shock. Something was not expected by the market. Okay? Do you see my point?
Professor,
Yes.
but in the last class you said that if for some reason we had high inflation and we were expecting an increase, that was not a shock. So
No, that's not a shock. Therefore, interest rates, if the market expect that interest rates are going to increase, the short part of the yield curve, basically interest rates at the very short run, are going to increase because they know that the bank is looking at inflation,
They
and
price-
therefore they price already that sugar.
The problem is if the expectation, for example, is that they are going to be 4 and they become 5.
Exactly. But right now it's saying like before the meeting, okay, we expect those interest rates. We are discounting all the information that we have in the economy, and we are discounting that these are going to be increasing interest rates. Okay? But then imagine that right after the meeting, you know, the yield curve do something like that. Okay? This variation is what is telling me that there is a surprise. Okay, we were discounting that interest rates were going to increase, and suddenly they didn't. Therefore, we changed our expectations, and this is the shock. We are isolating the shock.
So when the result is not what you expected, that difference is the error in your
The shock, or the shock, or the decision over and above what these guys have decided, over and above what's written in the newspapers.
But the difference between the real output and the expected output, that's not the whole shock, because
No.
maybe it's a bad
Yes,
forecast.
but in this case, they have all the information 15 minutes before, okay,
Right.
and they have the power to not to react, or the power to react. Okay, they have to, they can decide whatever they want, okay? This is the thing that I told you when we were talking about this thing, okay? And what I expect from you is that you are all here, you suddenly stand up and leave. This is a shock, this is a decision. The expected path is that you stay. But you are free to say like, fuck you. Okay? And you leave, that's a shock. Okay? And you cannot imagine how many shocks I have in teaching, okay? In my history of teaching, I have had all type of shocks. Okay? I remember one year that I trust you guys, okay, and then say, okay, you can do a take-home exam, but the only condition is that you don't copy. Okay? I really trust you, okay? And then you were so stupid that you can read the same names in the math codes for all the variables. Okay, what is the probability that you and you working separately have all the variables in your codes with exactly the same name? Pepita, Juanita, okay? Basically the variables are called whatever, okay? I know that you copy, okay? But that was a shock, okay? Then the point here is like these guys, 15 minutes before the meeting, we know the information that they have, okay? And then 15 minutes after, they say different number, okay? That's not an error, it's a decision, okay? That they made over and above, okay? We expect, you know, but they say like, no, I don't want to increase interest rate for some reason, okay? Clear? Then this is a typical way of isolating shocks.
And also when, for example, there is an expectation of interest rates,
Yes.
for example, central banks try to change things to adjust that expectation, or they wait.
No, yeah, see your point. Central banks are not random number generators, okay? Usually they see what the people see and they will react in the same way. But they have the power to do other things, okay? And you are getting into the difficulty of interpreting monetary policy. Right? You know, it's like over and above what everybody is saying, you decide not to, okay? Or you decide to wait until the next meeting, okay? This is, okay? But the same happens with fiscal shocks, okay? How can you have fiscal shocks? Okay, suddenly we decide to have los mejores Sanfermines de la historia, okay? We spend millions of euros, okay? And over and above what is expected to have, okay? No, this is the power of the policy maker, shocks, implementing shocks into the economy, okay? And that's the thing, it's like shocks are supposed to be shocks and we try to isolate all the information that they have, and we understand the change in it, okay? Then, if you have this possibility and you put shocks into the model, you don't need to do a VAR. You already have a shocks. You don't need to estimate a VAR saying monetary policy shocks are whatever. Monetary policy shocks, no, you have already the shocks. And the only thing that you have to do is to do this regression at different horizons, and that's it.
So that is if you have already the shots.
You have already the shocks. Okay, there's a way that we can get the shocks. Okay? Okay.
I'm sorry.
Then, yes.
Would the fiscal policy shock would be like the same thing that happened with the SOCIMIs, like the REITs, like they removed the fiscal incentive?
The fiscal incentives, for
For the
example.
SOCIMI.
Exactly, or yes, or
So
any
the
type
PSOE,
of-
the PSOE delayed that policy. What did they do? Did it isolate like
that was a
shock?
that was a shock. That's a monetary was
So like less
fiscal shock.
other countries were registering SOCIMIs in Spain, so that's why you guys decided to delay.
Exactly, that's a shock.
But that was like kind of like obvious.
No, but basically how do you isolate fiscal shocks? Again, reading all the material from the governments, okay? All the decisions from the governments. And obviously these decisions are endogenous. Let's say, if there is a pandemic, we increase government expenses, okay? If we, if we react to these things, okay? Then you have to isolate, you have to instrument these variables, saying like, what is the knowledge that these people had before this period of time? And then you isolate the shock component.
So I have
Okay.
a question
Yes.
on that. It's like, for instance, the Trump's tariffs.
That's
So like there was a lot of conversation on that particular legislation for months, right? But like for the U.S., I'm just assuming like this is my trend of thought. So the U.S. might not have been a big shock, but for the other countries that didn't know the tariff percentages, might have been a shock, right?
That's an external shock to the economy. Okay? These are the kind of shocks. We try to isolate these things and we try to separate this. Okay? But Hannah, your point is that as you can see, we have to instrument the variables. Okay? We have to find the information set and then trying to what is the part that is completely IID versus the part that was expected according to the information in the economy. Okay? In this case, for the monetary policy, we have this possibility of isolating just the changes associated with the shocks. Okay? Okay, what do you expect? If I isolate these shocks in monetary policy, and I make this regression of these shocks, some controls on growth rate of GDP in T plus 6, what do you expect is going to happen? What's going to shocks in monetary policy? When you have positive shocks in monetary policy, what is the meaning of positive shocks in monetary policy? Monetary policy is less, basically interest rates are lower than expected. Okay? This is positive monetary policy shock. Okay? And if interest rates are higher than unexpected, okay, the decision is to increase interest rate, that's a negative monetary policy shock. Okay? Then positive implies lower interest rates than expected. And negative implies higher interest rates than expected. What do you expect for this coefficient to if this is on GDP, and if this is growth rate of GDP, or if this is inflation? What do you expect is going to, what's going to be the sign of this coefficient?
For what outcome?
I don't care. If you can put him, I know they put inflation. What do you expect? Shocks in interest rate are going to have an effect on inflation?
Negative.
What? When you have a positive shock, inflation is going to go up. Interest rates are lower than expected. Okay, inflation is going to go up. Okay? You have a negative shock, okay? High interest rate and inflation is going to go up, down. you are going to control inflation. You expect this coefficient to be positive. Okay? And the same with in GDP growth. Okay? When you have a positive monetary policy shock, interest rates are lower than expected, the economy, you allow the economy to grow. Okay? When you increase interest rate higher than expected, this is going to be a positive relation. Okay? Okay. But there is a paper by Agripina, I don't remember the name. When they isolate these shocks, they do this regression and they find the opposite side. Okay? When you have a positive shock, the economy, basically interest rate, inflation, when you have a positive shock, inflation goes down, and when you have a negative shock, inflation goes up. ¿Me seguís o no? Okay, you have a positive shock, I expect the interest rates are lower than expected, okay? Then I think inflation is going to increase, okay? And if I have a negative shock, inflation is higher than expected, interest rates are higher than expected, I'm controlling inflation, and inflation should go down. But they do this regression, and they find the opposite side. What's going on?
With regards to that, how realistic is the definition of monetary policy shocks as?
How
as
realistic?
like
This is
before-
as realistic as it can be. We are getting, we are stopping the work 15 minutes before the meeting. And we are, putting the clock again 15 minutes after the meeting. Everything that has happened during half an hour cannot be related to anything else. The only thing that has happened in this half an hour is the result of the meeting. Okay? The idea is that, it's saying like making sure, this is the same that instrumentalizing things, making sure that there is nothing has changed in that half an hour. Okay? But the results were the opposite. Okay? What's going on here? Okay? Then what they did is to relate the shocks with information from consensus forecast. No, consensus forecast is this one second. Contraction in monetary surprise leads to a higher expected inflation, okay? From they use information from the Green Book. What is the Green Book? The Green Book is the material that the governors have in the meeting. Okay? The material that the governors have in the meeting. Okay? Then they relate shocks with this material, basically in the internal forecast for inflation, internal forecast for expected inflation, internal forecast for GDP, a set of internal values, internal forecast. And they find that there is a relation between shocks and this internal forecast. Shocks are not shocks. These guys have information inside that is the market do not have. Okay? But this information was before the shock. Then this is not a shock. This is information that these guys have. Then what's going on here? When interest rates, if we expect an interest rate of 5%, and they decide the interest rate to go to 4%, we say, wow, a shock in monetary policy. The monetary policy is too loose. Therefore, we expect inflation going up. Okay? This is the conclusion. But this is not true. Okay? This is not a shock. They are seeing other things that we are not seeing, okay? Telling you that, inflation is going up. Okay? That's why, I'm sorry, that inflation is going down. Okay, exactly. Wait a second. Un momento. Yo espero, hay markets.
That's a positive shock.
Wait a second. Markets expect 5%. That's in my experience. Markets expect 5% because they think that inflation is too high. Inflation is too high. Therefore, the federal fund should increase. Okay? But what happened is that what we realize is that inflation, we have information telling us that inflation is not as high. Okay? Therefore, we think inflation is low. We keep interest rate low because inflation is low. Okay? Therefore, this is not a shock. Then the relation between them, what happens? This is not a shock. This is what is needed. But these guys are saying that this is a shock. Okay? Joder. Déjame un segundo, por favor. Un momento. The only thing that I wanted to illustrate is the importance of having good socks. You see, the contraction in monetary supply leads to higher expected inflation. Vale, perdón. Okay. Let me tell you that. Imagine that the markets are expecting 4%. Markets are expecting 4% because they say inflation is not too high. Okay? But the Fed funds increases to 5%. Okay? The Fed fund increases to 5%. This is a contracting monetary policy shock. Okay? And then what we expect that the inflation going down. Okay? But what happened? That, okay, markets were wrong. Inflation, we have a lot of pressure from inflation. Okay? And then we are basically acting to the high inflation. Okay? Therefore, inflation keeps up. Because if we are seeing that inflation is going up. The markets do not see what we see. The market thinks that inflation is doing something like that. Then we react to this high inflation that the markets are not seeing. Then given that we react to this high inflation, the markets say like, wow, you are being contractionary. But we are not. Okay? We are reducing inflation a little bit, okay? Because we are reacting to this. But the markets are very surprised that how come you have increased interest rate and inflation is still very high? Because this is not you are not seeing what we are seeing. We are saying a high inflation. Exactly. Then what they did was to react, to relate these shocks to this information that the Fed had before. Okay? And then what are shocks? Shocks are the errors of this relation. These are real shocks, not these shocks. Okay? Then everybody that did the paper based on these shocks is wrong. Because the true shocks are these shocks. If you do local projection based on this thing, you are getting different, completely wrong results because your shocks are not well defined. You have to do local projections with these shocks. Yeah.
But if you do like your relations with that shocks, I mean, it's not is it that you're doing it wrong or that your interpretation?
No,
has
you are
not-
doing it wrong because these shocks are not shocks. These shocks are contaminated by endogenous variables. Then you are going to say, you know, when I have a shock, when I increase monetary policy, okay, inflation goes. When I increase interest rate, inflation goes up, and you will be wow, very surprising result. I increase interest rate, inflation goes up. I have a positive shock in interest rate, and inflation goes up. What? It's wrong.
Because you need to interpret it like that.
No, because these shocks are not
The real.
they contain information about inflation already. Therefore, when you increase interest rate, it's not a surprise. It's that, you know, inflation, we have information about inflation going up. Then the only point that I want to make is like, your local projections are as good as your shocks.
Perfect. And then,
Yes.
what's a real monetary shock then?
Then what they claim in this paper by Miranda, Agripino, Rico, AJ Macro is that these are
So the market believes that the interest rate is going to be 4% because they are overestimating inflation.
they are looking at other things.
They don't
They
think
they
that.
don't have the information that the ECB has.
So the ECB knows that inflation is going higher than.
We
the
have
market
higher
thinks.
expected inflation that the ECB that the market
And the
expects.
market, and why doesn't the ECB
Explain.
transmit that?
Yeah, that's another policy. It's like monetary policy transmission. Okay, saying like after the ECB take that decision, they explain why they take the decision,
Mhm.
and then the market can learn from this. It's like, okay, the
Right.
decision is taken based looking at this, that. They have to make a statement after the decision, and then a lot of people look at the details of that statement in order to understand. And there's a whole literature in monetary policy transmission, in monetary policy communication.
And the ECB knows the market expectations.
The ECB knows the market expectation and something else,
Right.
and internal information. And this internal information is what is biasing these shocks,
Mm.
because you need these shocks.
And doesn't if the ECB does not communicate in advance,
No,
it's not harming the market?
no, all
Because-
these documents are confidential. And
Okay.
all the internal documents are confidential.
But you understand what I say, like if the market.
Why do you
believes-
want to explain? Okay, there's a lot, there's a lot of papers on, is there any information content in the speeches from the governors or the people that work on the committee or the governing council that's kind of give you some hints about things that they are looking at? Okay, and a lot of literature on trying to understand monetary policy decisions based on speeches. Okay, saying like what is the content of these
Yeah.
speeches about what's going to happen in the monetary policy decision. Okay, but then the point is that is saying like, but you understand the only point that I want to make here is like local projections are not free. Okay, saying like, I put a shock, but you know, el cura de mi parroquia ha puesto en la página web, and I'm going to put these shocks because, you know, this guy is a very sane guy, and I'm sure he knows a lot. No, you cannot do that. Okay, you have to isolate real shocks. Is a big issue.
Perfect.
Yes.
I have a question of why doesn't the central bank communicate every single information if they don't they want their shocks to actually be effective? Like, so if they
Yes.
if they eliminate that asymmetry of information,
Yeah,
they can
okay,
make-
you can put, I mean, they are, okay, yes and no, okay, there are some, I mean, these are the rules of the game. You don't want to have a central bank that is, you know, it's a big deal, okay, saying like, you know, receive information, get into the trade without thinking, it's not an automatic decision, okay? Based on discussions, whatever, okay? Okay. But then the point that I'm making, the only point that I want to make here is, you know, the definition of the SOX matter. And then, how do you define SOX when you have known all these things, okay? And I just want to make a point here, okay? Because there is something here that is a little bit different than the standard econometrics, okay? Let me tell you first, let me introduce you to, do you know what are instrumental variables? Okay? How you study instrumental variables? Okay? What is the purpose of having instrumental variables?
Isolate the effect of one variable, no?
Isolate the effect of one variable. You have variables in the right hand side that are endogenous. Okay, you put something exogenous to the system. Okay, try to explain what is the purpose. Okay, great. Then let me. Okay, when you do instrumental variables, have you studied instrumental variable in this master?
Yes.
With
Correct.
okay, in econometrics 1.
Yes.
Okay. Then the idea of instrumental variable is the following. I have a regression here that is endogenous, okay? And you understand that if I don't do instrumental variables, beta is biased. Okay? Then the thing that I can do is to stay least squares, the more typical thing. Do you remember that? Okay? Basically, making a regression of t on some exogenous variables. Let's say this is t. Okay? This is completely exogenous. Okay? You make this regression, you calculate xt hat from this regression, and then you put xt hat here. Okay? And this is not biased anymore. Okay? Because this comes directly from the exogenous variable. Okay? These are the movements in xt that are not related to yt, because they are only related to the instrument that you are considering, that is the given information. Okay? Then we do instrumental variables. Then in order to isolate the effect of shocks, we want to talk about, in this case, oil prices, then we become instrumental prices. Okay? There's a lot of literature on instrumental oil prices. Okay? From using, here you have a kind of summary of this literature that you have here. The oil shocks. We have narrative identification, read the historical record, perform a series of dates, okay, on wars, revolution, whatever, structural behavior with sign and dynamic restrictions, Bayesian structural behavior with elastic price, okay. There's a lot of literature on trying to isolate movements in oil prices that are completely, they are shocks, that are not expected, okay. Whole literature on that, okay. Then imagine that I believe one of these papers and I extract the source. Then in order to address the point that I'm talking about, in terms of the relation between shocks in oil prices and product of cheese, the price of cheese, your point is that right now my import response functions are biased because oil prices contain also information about the Spanish economy, okay, in an indirect way. Then I have to use shocks. Okay? If I don't have any information on how to use shocks, there is always the possibility of doing instrumental variable estimation. Okay? Instrumental variable estimation in this case have a little problem. Okay? What are the standard conditions for instrument? Okay? Okay? Then the point is the following. The problem that I have when I put here shocks, oil prices, imagine that I put oil prices. The problem that I have with oil prices that you are aware that they are related to activity in the world, okay? They are related to Trump decisions, okay? They are related to OPEC decisions. Okay, all these things are here. Okay, all these things are here. Okay. If I want to isolate one particular part of this thing, okay, if I want to understand how some decisions affect oil prices, okay, if I want to isolate, or a lot of people are saying like, I want to isolate how the wars and all the external shocks that are not driven by internal demand or world demand, I want to isolate those shocks. Okay? Then you have to find an instrument. Okay? Basically, what you are going to do is to make a regression of oil prices on a set of instruments that you are going to be consider that explain this oil price. And then what is the point? You are going to make this regression, and in this regression, you are going to make a regression, and you are not going to put here oil prices. You are going to put the oil prices that come associated with the reasons that you are considering that are important. Okay? Therefore, you isolate oil prices from world demand. Okay, if we do that, and this is the point that I want to make. If we do that, we have a set of things that we have to be careful about. First of all, my instrument has to be relevant, making sure that my instrument is correlated with these shocks that I'm interested in. Okay? Let's say Trump decisions or whatever. I want to find instruments that are related to this particular part. Remember that oil prices contain a lot of shocks. Okay? In addition to that, oil prices, my instrument has to be unrelated to all the other shocks that I don't care about. Okay? Or my instrument has to be uncorrelated with all the shocks that are due to world demand. Okay? I want to isolate that particular. Okay? And in the particular case of local projections, you have to be very careful. Because your shocks, your instrument has to be also not related to future shocks. And why is this? Look, the problem that you have with local projections is that in the left-hand side, we are going to put T plus H. And T plus H contains a lot of future shocks. If your variable is related to future shocks, then this is going to be biased. Okay? And then look, what I'm talking about here. Imagine that I'm putting, this is not trivial because imagine I want shocks. For example, in the case of monetary policy shocks, I want shocks that are not contained in anything that may happen in the future. Okay? Imagine that they have information about, imagine that the Fed has information about Trump conquering Cuba. Okay? These are not shocks anymore. Because they are acting to internal information, understanding that Trump is going to conquer Cuba. Okay? Then I'm going to say, when the interest rates increase, whatever, perhaps they are acting to that, okay, to future information. Okay? Then you need shocks that have to be orthogonal. They have to contain information about the things that you want to calculate. You want instrument that contain information about the things that you want to talk about. Okay? In this case, E1, the first shock. They are completely exogenous to the other, and they are completely exogenous to anything that is going to happen in the future. These are real shocks, okay? That are not trivial. Okay? It's not trivial to find these shocks. Okay? Then you can imagine the use and abuse of local projections. Okay? I get shocks from my parroquia, okay? And I put them in the model, I have shocks because the fish is so nice. Okay? Okay, what kind of social? Here I have also some lessons about how to use the instrumental variables, whatever, don't worry about that. What do I expect from you? Local projections are a shortcut to VAR, but we have two problems. First of all, the standard errors are going to be bigger than the standard errors of the VAR because of this thing of mean request, okay? Even that we are putting information about the future, okay? The they are correlated, they overlap. And the second, the definition of shocks is not simple. You need to isolate different definitions. Okay, this is what I wanted to say about local projection. I said a lot of things. Again, you have more in the slides. Okay, I can give a full course in local projection. Okay, the only thing that I'm going to ask you is making sure that you understand the relation between VAR and local projections. Okay, that you understand that it's a shortcut. Okay, that in VAR you isolate shocks. When we talk about monetary policy shocks in VARs, at the end of the day we have a definition, a statistical definition. We can have different definitions in different VARs of what is a monetary policy shock. To include monetary policy shock as an exogenous variable into like this type of regression that we do in local projection implies that we need to understand the definition that we are including, what type of definition we are including. Instrumental variables can help us to disentangle the information from exogenous variable, and this is basically like
How do you know that a shock is not correlated with future shocks if you don't know the future shocks?
No, you can check, okay, you can put your shock in your system, and you have to make sure that, okay, first of all, conceptually, you have to make sure that your shock makes sense, okay, saying that, you know, and then you can check if up to what point your shock is correlated with future behavior. If your shock is correlated with future shocks, and then perhaps it is not that very shock. These are very, very difficult to test. This condition is very, these are theoretical. It's a theoretical theoretical condition. It's very difficult to test in reality. Okay?
Yeah.
But you have to understand that when we put shocks, we mean shocks. Okay? Decision that does not contain any information from anywhere.
Right. So then shock is more like unexpected information, not only from the market, but also, like, more importantly, from the decision makers.
Yes, exactly.
Because if the decision maker has the information, only one
Imagine
person.
we are talking about climate shock. Imagine that we are talking about rain. Do you think rains are shocks? Rain.
You expect the rain.
You can predict rain.
We can predict rain, therefore it's not a shock.
In Pamplona, they are shocks.
That's what I see. Okay, but the point is like, when we talk about climate shocks, okay, up to what point La Rana was a shock?
Depending on also on the time you say.
On the time you say, depending on the only point that I'm making is like you are putting, okay, what is the time frame whether you are using, you have, imagine that I use monthly variables, okay, perhaps the month before, we had no idea about what was the magnitude of the 15, up to what point, if I say that, you know, imagine that I plan a wedding in Pamplona in June, okay, and it rains, I can say, oh my God, no, it's raining. Joder, por planear en Cádiz, hostia. Then there are shocks and there are shocks that are predictable, okay? Then what is the part that is unpredictable is something that the whole thing, but the problem is that the whole analysis relates on that.
So there are very few shocks in the world.
What?
That there are very few shocks in the world because
You can local projection is full of papers.
and can you name 2 shocks? I'm not asking.
If I think about that, COVID was a shock. Sometimes.
Yeah, but maybe no.
Okay?
Maybe not like that.
COVID was a shock.
COVID?
If I think about that, I would say COVID was a shock. That way.
Every crisis is a shock, no?
No.
So the Great Depression and stuff like that is not a
Then,
shock.
for example, the Great Recession was a shock or not? Was unexpected?
But some people were
I mean,
expecting it.
2007.
In 2007.
It was unexpected. Everyone saw like the
We are going to
bubble
see
went up.
that. We are going to we were on exactly that.
And there were leading indicators.
Yeah.
With COVID, there was, like, for example,
That's the thing.
Yeah, but the
Like,
market, yeah, it was
But
like
in
the
our
overview of the
world,
market was,
exactly.
and there was a whole thing on price, they weren't responsible, they're still offering most products.
But the point is that it's like they are not okay. It's the point that
Yeah, this is only
If we have a piece of information and we know it, can we record it in actual case?
you are are saying that, exactly. You are saying that this is a very good. We have a piece of information that we are ignoring. Can we call a stop when this is we are ignoring the information.
They were standing the guidance and then it is. So there's that information, but this is better than not know.
Yeah, but how many viruses then we react? Your point is well taken. Let's say we knew that in China something was happening, okay? And we kind of said like, whatever, okay? But if we react to every virus in China, then we are not going to leave this. I mean, we are not going to leave home ever, okay? Then let's say like we recently had another virus in the boat. We want to. How much do you want to react to this thing? Expose is very easy to say. We are going to talk about expose as in the example. Okay. We had information or not. It was so. There was a piece of information that I was ignoring. No, at the end, this is not trivial. Okay. But you will see that the literature is full of paper on local prediction considering shocks. And in particular, we act like we have this herding behavior in economics. They say that if somebody publishes the shock, we use the shocks and we don't care. Okay, without understanding at what point the shocks makes sense or not. This paper that I was telling you about killed 20 years of literature in monetary policy. Okay? There were 20 years of papers using the previous shocks that I was telling you. And this paper saying like all these shocks are wrong. All these papers are wrong. Okay, then what else? I wanted to talk about this local projects. Okay, one time. Okay. I'm going non-stop. You need to pee quickly, you can pee quickly. But 5 minutes of peeing, okay? And you want to do something bigger, you can also do something bigger, but in 5 minutes. Okay? 5 minutes. I already started. Estos probaron que es un dicho, nadie lo había probado.
Y pues eso merece casi un referéndum, porque deshace la política monetaria.
Bueno, que pues hay que.
Ya tenía ese concepto de monetary policy shock también parte de macro.
Sí.
O sea, los profesores también les dañaron la línea de investigación.
Nada trivial.
Si quiere retrasarlo 2 horas.
Bueno.
Sí, tengo un carne filter, ¿verdad? Y lo pruebo en samples. Me da una correlación de 193. Cuando lo pruebo los samples, cae a 169. Es normal. Escribí comentarios aquí.
Una predicción of sample muy jodida. Of sample muy jodida.
Súper práctico.
Por eso no me preocupo, de hecho estoy viendo paso a paso. En ese país en primer,
Locura, ¿no?
la idea está, sí, mucho más complicado.
Cada país tiene un delegado en el Banco Central cada país tiene el gobernador, y el gobernador de cada país tiene la opinión del gobierno. Y todos los países tienen el mismo peso. Eso en función de su PIB.
Okay.
Técnicamente de la Constitución que hicieron al principio de cómo se van a la Constitución a fondo de la relación mediante quantitative regression. Okay? All the central banks, we all talk about something called growth and risk. That is familiar to you because you have studied finance value at risk. No? What is value at risk?
Because that was first class. It was like maximum loss or the
And we all have these things. Okay? We all have these quantitative regressions in this. And the idea of this paper by Adrian Domenico Iannone, Tobias Adrian y
Oh, Yavchenko.
well, the idea of this paper is very simple. It's saying like if we want to relate what is the relation between credit variables and the economy, the most comprehensive way to measure credit conditions in an economy is the national financial condition index. What is the national financial? I'm plotting here national financial condition index. What is the idea of national financial condition index? Is a principal component, you are familiar with that, of 260 variables related to credit. Okay, in general. Then, as you can see here, when national financial condition index goes up, credit conditions are tight. When national financial condition index goes down, credit is loose. Okay, what's the meaning of credit being loose? Basically, if you go to a bank, I remember here before the great financial crisis, basically, if you went to a bank asking for credit, they gave you credit. Okay, basically they didn't check that much. Okay, credit being loose, the credit conditions are loose, or the credit conditions are tight when national financial condition is high. Okay? Then what they did is to, if we want to relate growth rate of GDP with national financial with the credit condition, let's do the growth rate of GDP and national financial condition. Okay? They also have different horizons, different 1, different 2, different 4. Okay? But basically the idea is, okay, let's make the graphs. You make this regression, you understand that basically what you are saying, okay, imagine that you make this regression, you're thinking like, okay, when the national financial conditions are high, basically credit conditions is tight, perhaps we are going to have a little bit lower growth than expected. Okay? But the idea is not that. Okay? The idea was saying like, let's do this thing in quantiles regression. What is the idea of quantile regression? The idea, in order to show you the idea of quantile regression, the best thing, I did a simulation exercise and I'm going to show you a graph that perhaps can summarize the intuition. Okay? Okay. Imagine that I have two variables, okay? Imagine that I have two variables, x and y, okay? And imagine that I make a OLS regression, this is the black line. If I make an OLS regression and I have a black line, what I'm saying here is what I'm trying to minimize when I do OLS. What I'm trying to minimize.
Where errors.
La suma de residuos.
La suma de los cuadrados de los residuos. Mínimo cuadrado de los. O sea, I'm minimizing the sum of the square root of this. Okay? 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 Look at this thing. Let me tell you the intuition of that thing. Look, if I have, let's say, I want to create, basically estimate a line, this is the thing that I'm going to say, that is going to give me, let's say, I'm going to minimize the difference between this and this to the power 2, okay, this and this to the power 2, okay, and this is the line that makes this variation the smaller, okay, to the power 2. This is what I do when I estimate by OLS. Imagine that I try to estimate instead of the sum of the square of the residual, the absolute value of the residual. Okay, saying like not to the power 2, but just the absolute value. Okay? The idea, this is the same that calculating basically the one is the same that trying to minimize it's basically by going through the median of the residuals. Okay? You can see this is very similar to this. Okay? But let me show you something different. Imagine that I want to make sure that I capture the bad times. Okay? Basically, I capture the bad periods of times in one. Okay? What I'm saying is like I'm going to put a lot of penalty, okay? I'm going to write this line, and I want to make sure I'm going to if for this variation, this going below this red line, I'm going to put a weight of 9, and if I am above this red line, I'm going to put a weight of 1. Okay?
For the residual.
Eh?
For the residual.
Yes, exactly. Look, I'm going to put a line such as I want to make sure that the numbers below the line, the residuals, this minus this, let's say, if I am here, this is what I expect from this, okay? But I want to make sure that the numbers below the line weights 9 times bigger than the numbers above the line. Do you understand that what I'm capturing is kind of the behavior in the bad times? Okay? And this is very clear from this plot. It's saying like, I want to make sure that these numbers, I don't care about, look at this number, it's really huge, okay? I'm saying that I expect this, and this number is, the error is huge. But given that this error only weights, the weight is only 1, and the errors below weight 9, obviously are going to be biased toward capturing the bad numbers. Okay? Clear? And imagine that I do the opposite. Okay? I want to capture the good times. Okay? Then I'm going to put a lot of weight to be above the good times. It's going to have a weight equal to 9, and being below is going to have a weight equal to 1. Then I allow for these errors that are huge, and say I can be here. Yeah, joder, wow, what an error. Who cares? It's below. Okay? But I want to make sure that all the errors above are well captured. Okay? Then you understand that this line is kind of a model for the normal times. This line is the relation between x and y in the bad times, and this line is the relation between x and y in the good times. Clear? Hannah, I don't know if do you think it's capturing the intuition of quantized regression?
Yeah.
Okay?
I don't
Yes.
understand the why you differentiate between bad and good.
Because look, look at the green line, it's close to the big numbers here. Okay? Really big numbers compared with the value of x. Okay? These are really big numbers. And I want to make sure that I capture.
And the red line is the growth at risk as the
I'm just saying quantized regression. Okay? And I'm trying to give you the intuition of quantized regression. Okay? And either you minimize. But first of all, a couple of things that I want to tell you. In all cases, in all the regressions, you are using all the information. Okay? It's not that you are saying, I only care about the big. No. You are using all the information. Okay? But you want to make sure that you capture the extremely good numbers. Okay? Look, the economy is booming. Imagine that this is GDP. Okay? And this is the national financial condition. Okay? What I'm saying is that, wow, the economy is booming. Okay? Oops, I want to capture that. Okay? And now, wow, the economy is in a terrible shape. Okay? I want to understand the relation in the terrible shapes. Okay?
I would say good and bad because the y-axis is a...
The y is determining
The y is
where I am.
Okay.
Okay? It's saying like, what is the relation in the good times and what is the relation in the bad times. Okay? Clear? I can estimate this. How I estimate this mean is minimizing this function. Okay?
What did you say? ¿Qué pasaba? No, in English. What did you say about like assigning weights?
Yes, look at this thing. Let me show you the function that I want to minimize. Okay? Look, the point that I want to make here is the following. I'm going to find 10 betas. Okay, not one, but 10. And these 10 betas are going to minimize this function. What is this function? Look, imagine that tau is 0.5, okay? Then what I'm saying is like, I am going to, this is the expected value, this is the observable, this is the expected value, and this is the positive penalties. This is the observable, this is the expected value, and these are the negative penalties, okay? If this is 0.5, I am penalizing the same, the positive penalties than the negative penalties, okay? And this is absolute value, okay? Therefore, this is the estimator of the median. Okay? If this is 0.9 and this is 0.1, okay? Look, I am putting a lot of weights to the positive penalties and being above this thing, and I'm putting less weight to the lowest weight, okay? Then I'm going to play with this. This is 0.9, then different deltas, different decides are going to give me different lines. I just present you 3 lines, but I can have 10 lines. Okay? And this is the function that I'm going to minimize for every value of theta, tau. Tau 0.1, then I have one line. Tau 0.2, then I have another line. Got it? Okay? And that's it. Okay? Actually, now this is a command in MATLAB, one type. Okay? I'll give you all the values. But I want to make sure that you understand what you are doing when you do one type. Okay? And I think the graph that I show you is very useful. Okay? This see what happens. Okay? Then these guys that are very smart, okay, they did this one-time regression, and then what they did was to say like national financial condition index is related to GDP in 10 different ways. Okay? Then I'm going to have 10 different values. Okay? Let me show you a little bit about these betas. But let me show you first why the paper is so sexy. In addition to the fact that Tobias Adler is a very sexy guy, okay, and he presents very well, okay, and he's recently he's director of the Met, that makes him more sexy. Young, tall, okay, powerful, okay, obviously the paper is successful. Okay, then what is the point of the paper? The point of the paper is like, you know, if I observe national financial condition index right now, 10 things may happen to GDP tomorrow. Because I don't know where I'm going to be, where we are going to be. 10 things are going to happen with GDP tomorrow, okay? It could be beta 1 national financial condition index plus 8, it could be beta 2 national, okay? 10 things may happen to the GDP. Okay? Therefore, I'm going to estimate for every period of time 10 possible values for tomorrow. In addition to that, let me, instead of having 10 possible values, let me adjust a t-distribution to this value. Okay? And look at the graph. They create this type of graphs. Okay? When you have a sexy graph and you are a sexy presenter, you have success. Okay? And this is the sexy graph that you know it makes a big difference. Okay? Say like only with this simple exercise, we can talk about all these things that are may happen to the economy. By the way, I don't know you noticed that nothing happens in this side and a lot of action happens in this side. Okay? And that's also very relevant. Say like, what's going on here? Let me show you the coefficients.
What are the axes? Year, growth, and the other ones?
This is National Financial Condition Index.
Okay.
Okay. And this is periods of time. Okay. And here is the density function of the forecast that you are forecasting.
Those are years. So like the x-axis are years. The years before.
No, I'm sorry. This, sorry, what you have here is, no, I'm sorry. These are years, 1975 to 2015. And these are the possible values for growth rate of GDP. So, okay? Growth rate. So growth rate of GDP. Okay? Then, National Financial Condition Index in 1975 was whatever. And then, associated to that, this is all the things that can happen to GDP growth. Okay. National Financial Condition Index in 2015 was whatever. And, you know, basically this is what the density function of GDP growth. Okay? You put all these density functions together, and you represent all the things that can happen to you. Okay, but let me show you the coefficients, because I think the coefficients, in the moment that you see the coefficient, you are going to understand the difference. You see the paper. Let me show you these coefficients. Yes, this is what I want to show you. Okay? Look. In the lowest decile, okay, the coefficient is minus 2.5, okay? And in the biggest decile, the coefficient is basically 0. Okay? Look at this thing.
Can you repeat that?
Yes, look at the coefficients, okay? These are the different deciles here. Let me come back to the lines that I have here. I have a red line and a green line, okay? These guys are telling me the coefficients of the red line is minus 2.5. The coefficients of the green line is basically C. Okay? Imagine that, look at this thing, this is very important, because let me come back to show you the national financial condition.
That's like an asymmetry, no?
And C. Okay, look at this thing. Look at this thing. Let me write down here the equation. Remember that we have 10 coefficients here. Okay? What it's telling us is the following. Imagine that we have a big number for national financial conditions. Credit conditions are very bad. Okay? And remember that we have 10 things that they happen to be more. Okay? And remember that it may be when if something terrible happens tomorrow, okay, and this number is very high, this number is going to be minus 2.5, something terrible may happen to the GDP. Okay? If national financial condition index is very high, there is a possibility that something terrible happens to you. If national financial condition index is basically 0, we are in normal time. I'm sorry, if national financial condition index is very high, something terrible may happen to me, but the economy could be terrible, but if the economy is basically, if we are in the good time, this is equal to 0, okay? Then basically it's telling me we can go to minus 3% or something like that, but we can go from minus 3% to basically, in the good times, this is 0, then nothing happens here. Okay, it's 0. Okay? This is very high. Then if this is low, let's say this is close to 0 in normal times, okay, imagine that right now this is 0, okay? This is telling me, even that this is 0, even if we are in a terrible economy, nothing is going to happen to me because this is 0. Okay, and in the good times, basically I have the same number that in the bad times because the coefficient is equal to 0. Then what it's telling me is that national financial condition index, okay, when the credit conditions are bad, the economy could be terrible or could be 0, and when the national financial condition index is good or is close to 0, okay, basically the economy is, okay, nothing happens. Basically we are in 0 or in 0 because we are basically here, okay? Okay? Then basically national financial condition index, when it activates, what it's telling me like, oh, something terrible may happen, something terrible may happen. It doesn't have an effect on the mean, it has an effect on other moments of the distribution. Okay? The possibility of something terrible happening. Okay? Then it's not like when the national financial condition index, the economy is expected to go down. No, it's when the national financial condition index increases, something terrible can happen to you. Okay? This asymmetry is, this is the asymmetry that you can see in the previous graph. Okay? This is the asymmetry that you can see in the previous graph. Okay? Look at this thing. Nothing happens here, but terrible things may happen when the national financial condition is activated. Okay? It's a completely different way of seeing the relation between credit and activity. Okay? Credit affects the possibility of terrible things happening to you. Okay?
Can you repeat what you said earlier?
Yes.
The difference in the NFCI is.
Yes.
is- I didn't
Look
have-
at the graph of the national financial condition. Okay? Sometimes it's positive, and sometimes it's basically close to 0 or small negative number. Okay? Then imagine that we are talking about bad conditions implies national financial condition index being extremely high. Okay? And then you put here a number extremely high, what are you forecasting? If you are in the good times, you are forecasting basically the constant. Okay, because this coefficient is 0. And if you are in the bad times, you are forecasting a terrible thing that happens to you. Because this number is
Can you give me more of the logic? So like the credit, I understand like when the NFC
Yes,
goes up, technically, it's like the economy, like the credit is tight, right?
The credit is tight.
Okay, so technically, yeah, so the B is 0.
No, no. Credit is tight. This number is tight. And remember that this number is multiplied by 10 numbers in order to give you what okay? Then when I multiply the National Financial Condition Index by these 10 numbers, I have 10 formulas. This number that is the good time is basically 0. Then basically I'm forecasting 10. And this number that is the terrible time is minus 2.5. Then I'm forecasting minus 2.5 times the National Financial Condition Index. Okay. Something there. Okay. What happens when the National Financial Condition Index are in good time? 0. Okay? This one then what happens? I'm forecasting again the numbers, okay? But when this number is close to 0, I'm forecasting for the bad periods, for the good periods of time, also 8. And for the bad periods of time, I'm forecasting nothing. 8. Then what is going to happen is when the National Financial Condition Index increases, you have a huge density probability of terrible things happening in your economy. It's not a linear relation, it's a very non-linear relation. Hannah, is that right? Okay. Okay? Clear? Yeah. Then, something that I don't like about this paper. I like about the paper that they came up with this idea, that it's a good idea. What I don't like about this paper, we talk in this class about the grade moderation. We talk about the grade moderation in this class? No. No? Something invented, no. Okay. Okay. I thought that. We saw GDP, we saw the autoregressive, we saw the Markov-Suchet model for GDP growth. Okay. Yes. Yes. Hold word. 5. The word 5. Okay. Let me hold it. Let me. You know what is? Have you heard about the grade moderation?
I mean, I know it exists.
What is the grade moderation? Okay, this is GDP growth, okay? From 1947 to before the COVID, just to make, because otherwise, do you see something here that caught your attention?
Yeah.
What?
The period from the 80s to the Great Recession.
Okay. This period?
It's like very stable.
Okay, and even with the Great Recession, this is just one particular observation, but you know, there is something here in the data completely different than this. Okay? That's the grade moderation. I discovered the grade moderation. Okay? The paper of the grade moderation is mine. My paper with the column. Okay? We were the guys that discovered the grade moderation. Okay? It's an American paper in American Economic Review. And we were the first one to see this. Okay? Why, if everybody can see these things, we were the first one to see these things? Okay? Because my grandmother can see that and she doesn't have an American economic. Okay? What is the point here? The point here is that what we did, if you run the code that you have for homework 5, and you run it with the data that you have right now, the model, you run it with data up to here, let's say, I'm going to tell you in the moment that we run this. If you run a Markov switching specification, okay, we run a Markov switching specification, and we found we estimate this model. We estimated this model, or this is the model that we estimated in problem 5. Okay, this is the model that we did in Formula 5. We estimated this model, okay, and then we got these results. Mu 1 was equal to 1.01, mu 0 is equal to 1.01. I'm sorry. We estimated this is the model that Jim Hamilton had, this is the model that we found in homework 5. But I was working at the New York Fed, and then my boss told me, you know, something is happening with the data, okay? Something is happening lately with the data. I remember the good old times when I could say something about the economy. Now I cannot say anything about the economy. Then, even though it was changing volatility, what I said is like, okay, I'm going to estimate a normal 0, but I'm going to change the volatility also. I'm going to allow for the volatility. We estimated this model and we got these numbers. Mu 0 is equal to 1.1, phi is equal to 1.32, sigma square of 1 is equal to 1 is equal to 4, no, 0.85. Sigma square of 2 is 0.35, T is equal to 0.9, and Q is equal to 0.7. What's going on here? Okay, and then we find something like this. That the economy was in state 1 and suddenly went to state 2 forever. Okay, look at this thing. In the moment that we saw this thing, the only thing that I knew in life was Markov switching. I didn't know if I wanted to be myself. But thinking a little bit about the results, I realized, oh, we have a big paper. Okay. If you go to internet and you put grain moderation, you find millions of okay, and we thought, okay, we have a great paper. Why we have a great paper? Look. There are tons of papers written about recession and expansion. You know, recession, expansion. Okay? And now what I'm saying is like, let me also have variance high and variance low. And if I allow for variance high and variance low, the data prefer to adjust to high variance. Okay? Here, low variance here, and that's it. Okay, that's the more important feature of the data. The data do not adjust anymore to high and low mean. The data adjusts to high and low. Therefore, if millions of papers have been written on recession and expansion, this effect that you see in the data is more important, more striking than the fact that you have recession and expansion in the data. Okay? Now, what was the point here? Okay? The point here is like, we had to find, okay, we had to document that there was a structural break in the volatility of the data. Structural break in volatility. Okay? What is the most standard? Have you studied structural break test in econometrics? No? You have never heard of choke test?
Yeah, but in Miami.
Your other, this is the typical thing. Okay, what is a choke test?
Basically, you take sample of the data, just a piece of the data, and you like progress if the mean is similar to the whole sample.
Exactly. Okay, the idea of a choke test is the following. Imagine that for your TFFA, I say like, you know, I want to know if the data generating process has suffered a structural break. Okay? I want to know if, for example, the Spanish economy behaved differently and after we got into the EMU. Okay? Then the idea will be I estimate the parameters of a model, and then I create an beta 1 XT. This is the model. So now I'm going to say I think they behave different. This is the model. And now I'm going to say I think the economy could behave differently after we got into the EMU. Then something that you can do is to say 1, 3 is equal to You understand the point? It's like I put a dummy that takes the value of 1 if we are after the EMU. Okay, then your model is going to be yt beta 1 xt plus epsilon t before the EMU, and yt times beta 1 plus beta 2 xt if we are after the EMU. And the only thing that you have to do here is to do a word test or an F test or whatever, or the significativity of this parameter. If this parameter is significant, the economy behaves differently after the EMU, and if this parameter is equal to 0, there is only one state. Okay? Make the intuition. Do you see the intuition? It's the typical choke test. Okay? And obviously here we have the problem with the choke test is that God has to give you a break test, a break point, saying like after the EMU or after we whatever, okay? But then what happens if there is no such an exogenous break point, okay? That you have to estimate this break point, okay? If you don't know if there is a break point or not, okay? If there is nothing that happens in the economy, exogenous to the economy that give you a break point, then you have to estimate this break point. What is the problem of estimating a break point? Look at this choke test that I gave you before. Under the null hypothesis that there is no break, you know, in the choke test, under the null hypothesis, this beta 2 is equal to 0, and that's it. Problem solved. But when you have to estimate this break point, under the null hypothesis that there is no break, the break point do not make any sense. Okay? This something called nuisance parameter. I told you about nuisance parameters. In Marcos, which is B and U. And in this case, it's also a nuisance parameter. These things do not make sense. This is a nuisance parameter. Okay? When you have to test something with a nuisance parameters, none of the statistics that you are familiar with works. Okay? You have to invest in another way of testing these things. Okay? In particular, the intuition is very okay. Then, in order to read all this material, all these papers are really difficult to read. Okay? The typical paper that is so full of integral that it doesn't matter if you read it like this or like this, you don't get it. Okay? But there is a recipe, and a very easy recipe. The idea is the following. How do you check? If you don't know the break point, how do you check if there is a break or not? And the idea, the intuition of this test is the following. You have a time series. When you don't know, after the EMU, you don't have this point. What can you do? Put the break point in the first moment in which you can have data, basically leaving 10% of your survey. Try to put the break point here. And calculate the wall test. Okay? Put the breakpoint in the next observation and calculate the voltage. Put the breakpoint in the next. That point in which you maximize the rejection possibility, the voltage is the biggest, is the most likely point for a breakpoint. You see my point? Intuition is very easy. You don't know the breakpoint, try all the possibilities, that one that gives you the biggest value for the rejection is the most likely. Okay? And the nice thing about these guys is they are so kind that they give you the distribution of that supreme of the wall test. Okay? You try different wall tests and they give you the distribution of the supreme of the wall test. Okay? Okay. Okay. This is the typical paper of Luis Alberico. Give you that distribution. I use that distribution. Okay? But somebody has to do the distribution. Okay? That's why we complement the theoretical pragmatism and the applied pragmatism very well. I use these results. Okay? Then, okay, we know how to do our test. In our case, we had a test for the variance, we could apply test for the variance. Okay? And we find that there is a break in the variance. Okay? Here, in 1984. Okay? It's a break. That's why this paper was so famous. Okay? It's not. Because my grandmother can see that, but my grandmother cannot do a formal test of structural break and apply all the knowledge that people have about structural break in the mean to apply for structural break in the variance. Okay? Then it's just a careful analysis of the data over and above what my grandmother could see. Okay? Then what we did is to say that what is the problem that we had in this macro switching specification? That we were imposing that the variance and the mean share the state. But perhaps we have two different phenomena here. We have the phenomenon from the mean and the phenomenon from the variance that has another macro switching process. Okay, and when we estimate this thing with two hidden macro processes, we can fit the data better. Okay. The point that I wanted to make is like great moderation is a fact. Okay, nobody questions anymore the great moderation, and actually, even with data, and actually you have seen the results. Even with data posterior to the Great Recession, okay, the economy is very stable, okay? And actually the point that we make in the paper is that it's not the business, it's not that the business cycle has been, it's there, it's the business cycle has been taken, okay? It's smaller, okay? But we still have business cycles, okay? And what is the point? The point that we make in this paper is the point, basically, what we find is that there is a break in GDP that is concentrated on the break in production of goods. No, there is no break in services, there is no break in structure, there is only production of goods. Okay? And there is no break in sales, and there is only break in production. And that has to do with the just-in-time techniques used to control inventories. Okay? The fact that firms control inventory very well, that implies that demand and supply move together, okay, because they know exactly what they have. Okay? And we put the example of Zara, we know this store Zara. They do this logistic, okay? They know exactly what they are selling, they have these machines, they know exactly how much they are selling, and they produce exactly what they sell. Okay? They don't produce. My father had a factory of sweaters and all that, and then he produced tons, and if he sold very little, next year I had to wear all the sweaters. Okay? And I was like, oh my god. Okay, I was like 1 period delayed from all the decisions that my father did. That was not exactly the best design. And then I have so traumático from that. Yo no ligaba nada. Until I left home, I never had a girlfriend. Okay? Because like sweaters. But then the point is that it's like production and sales move together, and production was more volatile than say before 1984. And it's the fact that you use these barcodes, something made at the micro level have a macro impact. And there are millions of paper on the source of the grain moderation. Okay? Nobody questioned that there is a grain moderation. Actually, even my grandmother can see that. But people question about the reasons behind the grain moderation. Okay? But it was a long story to tell you something that is this thing. Okay? Look at this thing. I don't know if you realize that if there is a recession associated with credit, was the 2007 recession. Okay? And look at the National Financial Condition Index, is not that high in comparison with recessions associated with oil prices that were not related to credit. For me, this is very surprising. Okay? What happened here? That all the variables that show up in the National Financial Condition Index are contaminated by the grain moderation. They are very volatile. Okay? That's why you have a lot of variation in this index, so that's period of time, and less variation after that. But this is related to the grain moderation. Actually, if you estimate the model starting in 1984, you don't find any of the results that these guys found. Okay? What happened in this period of time? These variables move, and the volatility also changes. That's why you will have terrible things, but they don't come from the National Financial Condition Index. They come from the fact that at that time we have huge volatility in the economy. Okay? And they don't take that into account. Okay? But they are sexy, the idea is good, whatever. Okay? Then the only thing that I wanted to tell you is that now that we know these things, we can do quantile local projections. Okay? In the same way that we have done local projection, we can do local projection with 10 coefficients. And therefore you can say, like, what is the effect of oil prices? Oil prices could have all these effects on the economy. Okay, depending on what happened in the economy. Okay? Be careful, because that's different of saying, and I just wanted to finish this class talking about this thing, and we have covered this and this. I don't know what I will do okay? But tomorrow I will finish a couple of things, and then I will go to the things that I want, and that's it. Okay? But let me connect with these things. Look, and I want to make sure that you understand this point very clearly. By the way, this is the last thing for the exam. Okay? Look at this thing. If I make a local projection,